if we write a number in this form, for example, x at power y, it gives a result, for example, z. If we substitute with numbers this equation, for example, if we write 2 at power 3, the result will be 8
8.
because 2 at power 3 means 2 times 2 times 2. And 2 times 2 gives 4, 4
4
times
times 3
8,
is
isn't it? So basically, we have 3 elements in this number. The first one is the base. X is known as the base here. Base. The number y, the number written at the position of y, it is known as exponent. Exponent. And the number z, the result, is known as the power. Now, these are the basic things about exponents and powers and bases. So numbers are written in exponential form. But now I'm going to explain some properties when we have 2 or more operations to do with exponential numbers. For example, the first property is this one. Sometimes kids have difficulty in understanding why x at power a, for example, times y at power a, why this gives x times y at power a. I'm going to explain this property with examples, with numerical examples. Let's take, for example, 2 at power 4 times 3 at power 4. I will solve this exercise with 2 methods. The first method is not using any property at all, but continue with finding the values directly. If we want to find the value of 2 at power 4, it is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And if we want to write to find the value of 3 at power 4, we multiply 3 by 3, it is 9. 9 times 3, it is 27, and 27 times 3, it is 81. If we find the value of 16 times 81, I'm using here a calculator only to be sure that the result is correct. 16 times 81 equals 1,296. However, we can make this operation by traditional method to make a review in multiplication if you want. Do you know how to do the multiplication of 2 digits numbers with each other in column?
Yes, yes, sir.
Okay, so let's skip this part. Now, if we use the property of exponents, the property that I have written here, we would have 2 times 3, all this at power 4. If the result of this operation is the same as the previous result, we can say that this property is correct, is okay. Let's try. Let's find 2 times 3 is 6. we have 6 at power 4. 6 times 6 is 36. 36. 36 again times 6, it is 216. We multiply by 6 again, and the result is 1296.
96.
So since we got the same result in both cases, we can say that this property is correct, isn't it?
Yes, sir.
Yeah. Okay. Now we will see another property of powers and exponents. The second property is this one. If we have x at power a times x at power b, the result will be x at power a plus b.
Mm.
Let's prove this. Let's see whether it is correct or not. Here I'm making the operations. Uh, let's take 2 at power, for example, 3 times 2 at power 4. The first method is without using any property at all, but making the operations regularly. We will find first 2 at power 3, which is 8. We found it here. It is 8 times 2 at power 4 means 8, multiplying again by 2 and obtain the number 16. And 8 multiplied by 16, it is 8 times 6 is 48. 8 and 4 other the tens we will carry. 8 times 1 is 8, and 4 makes 12. 128. Let's see whether this result 128 is obtained by using this expression here, the property. The x here is substituted by 2, the base. We have two exponents, a and b here. A is 3 and b is 4. I'm writing 3 plus 4. This means we have 2 at power 7. 2 at power 7 means multiplying the number 2 7 times
7 times.
with itself. So we have 2 times 2 are 4, 4 times 2 are 8, 8 times 2, the result is 16, 16 times 2 is 32, we have 5 so far, 32 times 2 are 64, and 64 times 2 are
128. 128.
so the property is okay, is correct. This property and this property are both correct. Now, I'm going to explain another property of exponents. I'm going to explain another property of exponents. The property number 3 is this one. If we have the with the not multiplication, but if we have division, for example, x at power a divided by x at power b, the property says that the result is x at power
A
minus b.
X.
Let's prove this. We will take 2 at power 5 divided by 2 at power 3. If we make this operation in regular mode, we will find 2 at power 5 is 32 because we have 2 times 2 times 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2 is 32. But 2 at power 3 is 2 times 2, 4, 4 times 2, it is 8. 32 divided by 8, it is 4. But 4 can be written as 2 at power 2, isn't it?
Yes, sir.
Now, if we write only if we solve this exercise by using the property number 3, we have x at power 5 minus 3. X here is represented by the number 2. 2, 5 minus 3. I did something wrong here because the minus should be written here.
Yeah.
It is equal to 2 at power 5 minus 3. So it is 2 at power 2. The result is 4 again in both cases. Now, the fourth property is this one. If we have x at power a, all this expression is at power b, the result is x at power a times b. Let's see whether this property is correct or not. We are going to explain this one by example as well. Let's take the number 3 at power 2, all this at power 4, let's say. Now, if we don't use any property, we would do first 3 at power 2, which is 9. 9 at power 4 means 9 times 9 times 9 times 9. Let's see the result. 9 times 9 is 81. 81 times 81 again. Let's see. 81 times 81. Sorry. 81 here times 81. The result is 6,561. 6,561. Let's see whether this result is obtained by using the property that we learned before. If we multiply these two numbers, we would have 3 at power 8, because we should multiply a and b here, 2 and 4, and the result is 8. Let's see. 3 at power 8. 3 at power 2 is 9. 9 times 9 is 21, 81. This is 8 at 3 at power 4. Again, we have other 4 exponents. So we have 3 times 3 times 3 times 3, 8 times 3 times 3 times 3 times 3. If we take these 4 exponents, the result is 81, because 3 times 3 is 4, 4 times 3 is 27, 27 times 3 is 81, and we have another 81 here. We multiply them by each other, and the result is again 6,561. Basically, these are the most important properties of exponents. There are other properties, but I'm going to explain now the least common multiple and the greatest common factor of two numbers, because they are very important when you are doing operations with fractions. You know, fractions, you have to add, for example, 3 21ths plus 4 28ths, and you want to find the common denominator of 21 and 28. Sometimes you have difficulty in finding the common denominator, so it is a very good thing if we learn today how to find the least common multiple, because it helps us a lot in calculating the common denominator, the least common denominator, because uh, I'm doing some review, an example with fractions now. Uh, let's let's say that we have 3 divided by 28 plus 4 divided by 21. So you don't know how to solve this example in a short way. Maybe you have learned that if you want to make this operation, here must be the same number, the same denominator, because fractions cannot be added without having the same denominator here, because the denominator means geometrically means in how many parts an object is divided, and the number of parts should be equal for two objects in if we want to make operations with them. Uh, Now, the first thing to do is to find the a common number that should be written here and here, but it should be the same. The first thing that comes in our mind is by multiplying this number with each other. It is a way, it's okay if you multiply 28 and 21 and you find the result here, 28 times 21, no, sorry, 28 times 21, we obtain 588.
188.
We can write here 588. It is not problem, but the problem here is that this is a big number, and it is better trying to find any number that is smaller than this, because if we make operations with big numbers, we have difficulty in finding the result. You must multiply 3 and 21 here, and again you have to multiply 28 and 4 here. It is pretty boring. 3 times 21 is 63, divided by 588 plus 28 times 4, it is 112, divided again by 588, and you should find the result here of 63 plus 112, it is 175 divided by 588, and so on. And after finding the result, you are not sure that this result cannot be simplified anymore. So in most cases, the result can be further simplified to obtain a fraction with smaller numbers but with equal value. So the best thing is to find a common denominator, but not being the product of these two numbers, because the product is very large, but if possible to find a much smaller common denominator and writing it here, and the operation will be shorter. Do you understand?
Yes, sir.
Uh, for this reason, we will repeat, because you maybe know very well, we will repeat how to find the least common multiple of two numbers. But we can find the least common multiple of more than two numbers in the same way. But first I'm doing for only two numbers, least common multiple, in short, it is written as LCM in your books. So
Yes.
of two numbers. Now let's take these two numbers that we are interested in, 28 and 21. I'm writing them right here. I'm writing 28 and 21. I will write them, and in the right I will make a vertical line. We will start dividing them by numbers that are prime. Do you remember which numbers are prime? The prime numbers are those numbers that cannot be divided by other numbers except one and themselves. Do you remember?
Yes, sir.
Prime numbers. For example, 2 is a prime number because 2 can be divided only by 1 and by 2. 3 is a prime number because 3 can be divided only by 1 and 3. But 4 is not a prime number because 4 can be divided by 1 by 4, but it can be also divided by 2 as well. So uh, a prime number is only a number that can be divided by 1 and by itself. So we should start dividing those two numbers with prime numbers, but starting from the smallest one. And the smallest prime number is the number 2. It is not the number 1 because the number 1 is a special number. It is neither prime nor composite because this is a composite number. The number 1 is not calculated in the list of prime numbers because it has only one divisor, only itself. It doesn't have two divisors, one and itself. So we start with 2. uh, don't worry if one of the numbers cannot be divided by 2. As long as at least one of the numbers can be divided by 2, we continue. So we have 28 divided by 2, it is 14. But 21 is written again in this form because it cannot be divided by 2. Again, we can divide 14 by 2, sorry, and we obtain the number 7. And here we have still 21 because 21 cannot be divided by 2. Now, neither 7 nor 21 can be divided by 2,
I
so
too.
we should continue, if possible, with the next prime number, with the number 3. If any of the numbers we have here can be divided by 3, it's okay. We continue. We see that 21 can be divided by 3, but 7 cannot be divided by 3. We write 7 without any change, and 21 divided by 3 gives 7. Now 7 cannot be divided by 3 anymore. 4 is not an option because it is a composite number. The number 5 is still prime, but 7 cannot be divided by 5. So we continue with the next prime number, which is the number 7. So we use the number 7 here, and we divide both numbers with 7, and the result is 1, 1. When the result is 1 for the two numbers that we have here written, we stop the method, stop dividing, writing them the divisors here. And so if we want to find the least common multiple of 28 and 21, it is enough if you multiply these numbers on the right. So we have 2 times 2 times 3 times 7. 2 times 2 is 4. 4 times 3 is 12. 12 times 7 is 84. We found a much smaller number than 588 that we had initially. So it is very good for us if we write this addition of fractions, but instead of putting 588 here, we put 84. It is much easier for us. Let's try. We had 3 divided by 28 plus 4 divided by 21. We should write the common denominator here, which is 84. Here we have 84 as well. 28 to become 84, it has been multiplied by 3, so we should multiply the numerator with 3, so we should write 9 here. To obtain two equal fractions, you said before, we can multiply both the numerator and denominator by the same number. So we multiply both of them with 3 and we get 9 divided by 84. In order to find the number 84, the number 21 has been multiplied by 4. This should be done also for the numerator. So we have 4 times 4, 16 here. The result is 25 divided by 84. Isn't it?
Yes, sir.
But you can say why we obtained two different numbers here. We obtained two different numbers because 175 divided by 588 can be further simplified by dividing both numbers with the same number. For example, we can divide 175 by 7. Let's see. 175 divided by 7. The result is 25.
Right.
And if we divide 588 by 7, the result will be 84. So we have the same result in both cases, only that in the second case, we don't need to do any simplifications as here. Sometimes the book asks you, the question is write the result in its simplest form. And it cannot be accepted in this way, even if the result is correct. But the book, maybe the question demands or requires that you find the result in the simplest form possible. So what had to do you here? You, at the beginning, maybe it is easier for you to multiply 28 and 21 and finding 588. But then it becomes more difficult because you should multiply these two numbers to obtain 63 and then to obtain 112 to make the operation with these two numbers. The result maybe should be further simplified again, and it is pretty hard compared to this method that involves finding at the beginning the least common multiple. So what does it mean, the least common multiple? The smallest number, the smallest possible number that can be used as a common denominator in these two fractions. So it is true that at the beginning we do this part, which is an extra calculation, an extra set of calculations, but after finding the least common multiple, we have much easier to find the result after putting the least common multiple as the common denominator here, because we don't need to make any further simplification. Do you understand?
Yes, sir.
Oh, okay. Now, could you find could you give the result in 3 minutes or 4 minutes if I give you an exercise to
Yes,
find
sir.
the least common denominator of two numbers?
Yes,
Uh,
sir.
let's write them here. Calculate the least common multiple of these two, or I'm doing the exercise like this. Calculate calculate 3 over 16 divided by 16 plus 5 divided by 24 in the simplest form. Write the result in the simplest form.
Okay, sir.
I'm going to solve it in the long way, so we will compare the results together.
$19.
Did you finish?
Yes, sir.
Okay. I'm writing the long way here. Um, did you get this number?
Yes, sir.
Okay, so you did it faster than me, and I was thinking by which number should I divide or should I simplify the result. I was not able to simplify with 8 from the beginning. I simplified no, not this, but the result here. I first simplified it by 4, and then I simplified it by 2 again, because I was not sure whether I should simplify by 8 from the beginning. So it creates a lot of difficulties, this method, the long method. But the short method you used, you found, I think, at the beginning you put 16 and 24 here in the list. So you divided first by 2 these numbers, and you obtained 8 and 12, isn't it?
Yes, sir.
Then you divide it again by 2, and you obtained 4 and 6. You divided again by 2 these numbers, and you got 2 and 3. again by 2, and we have 1 and 3 here. And then you divide it by 3 because with 2 cannot be divided anymore, this number. So we should continue with the next prime number, which is 3, and you obtained 1 and 1. Then you multiply these two numbers. 2 times 2, 4. 4 times 2 is 8. 8 times 2 is 32. 32 times 3 is 96. The least common multiple of these two numbers of 16 and 24 is 96, isn't it? No, not 96, 48. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. 48. So you got 48 here. We should write again here 48, but here it is easier to find which number should be placed in the position of numerator, because we see that 16 has been multiplied by 3 to obtain 48, and this should happen with the numerator as well. So we have 3 times 3, it is 9.
9.
We had 24 times 2 is 48, and 5 times 2, it is 10. And we have 9 plus 10, it is 19 divided by 48. So we got the same result as here, but in a much easier way. So the next concept includes the greatest common factor. The greatest common factor is a smaller number than these two numbers that we have here, but it is the greatest number possible that can be used to divide the first and the second number. For example, we know that 16 and 24 can be divided by 2 because they are both even numbers. But is there any greater number than 2 that can be used as a common factor or a common divisor of
Yes.
16 and 24? Yes,
Yes.
we
Yes.
have
It's
larger numbers than 2. For example, we have 4. That the number 4 can be divided by the number 4 is a divisor of 16 and 24 as well. But is there any larger number than 4?
it's
Yes, we have
it's
the number 8. The number 8 is still a common divisor of 16 and 24. But it is good if we guess every time. We start from 2, then from 4, then from 8. It consumes a lot of time to us. So it is a much easier way to find the greatest common factor. The greatest common factor of two numbers. I'm going to use this example because we have already the divisions made. Greatest common factor. A factor is otherwise known as a divisor. To find the greatest common factor, we can use the method of finding the least common multiple, but with only one difference. The difference is that we should not consider all these numbers here, but only the numbers that has been used to divide both numbers at the same time. For example, the number 2 has divided 16 and 24. We obtained here two different results than compared to here. So we round this because this number should be will be used for calculating the greatest common factor. We see that the number 2 here has been used in both numbers, and we obtain two different results here, 4 and 6. Again, the number 2 here has been used as divisors for 4 and for 6 together, but here the number 2 has been used only to make the division of 2. In the number 3, this number has not been used anymore, so it should not be considered to calculate the greatest common factor. And again, the number 3 has been used only in the second number, not in the first number. So again, this number should not be considered as a number of belonging to the greatest common factor. So the greatest common factor is calculated only by multiplying these these three common divisors. So the greatest common factor of 16 and 24 is equal to 2 times 2 times 2 equals 8. We found it at the beginning that 8 is the greatest common factor of 16 and 24. We found that the number 2 is a common divisor, but it is not the greatest. We found that the number 4 is again a common divisor, but it is not the greatest. And we found that the number 8 is the greatest common divisor of 16 and 24. And the best method to find the greatest common divisor is to use the same procedure that we used in finding the least common multiple. So you can find two things at once here. You can find both the least common multiple by multiplying all these numbers here, and you can find also the greatest common factor or the greatest common divisor by multiplying only the numbers that has been used to divide both numbers at the same time. Do you understand?
Yes, sir.
So even if we have more than two numbers, we can still use the same method. Let's try with three numbers. The demand, let's write a demand here. Find the least common multiple and greatest common factor of let's take 30 to 48 and 64. Let's work in parallel. You work in your notebook and I work here, and we will compare the results later.